Okay, so to kind of piggyback off of the special right triangles, we kind of lead into what's called the unit circle. We're going to find exact values from trig functions using reference angles and special right triangles, but we're going to fit them all on this unit circle. And the idea behind the unit circle is that you have a circle with a radius of 1. So now all these distances out to 0, 360 is 1. So here I got a couple ordered pairs for you. This would become 1, 0. Okay, this is going to become 0, 1. This would become negative 1, 0. And the only reason why it's negative 1 is because it's direction away from 0. And down here is 0, negative 1. Okay, now they're not the only important x and y values on there, but there's some key features. To go along with that, we are going to be able to find the sine of 0 degrees, 90 degrees, 180 degrees, 270, and 360 because they are all on those ordered pairs that I just talked about. Okay, now we talked about the sine of theta being y over r, x over r for cosine, y over x for tangent. Well, if the radius of the circle happens to be 1, what I can do is I can look at the ordered pair and call it good. So for example, the sine of 0 degrees is 0 because the y value at that point is 0. The cosine of theta is 1 because the x value of that point is 1. The tangent, remember, is y over x, so I'm going to take the y value of 0 over the x value of 1 and get 0. Come up to 90. Okay, we have sine is now going to be, I'm sorry, I wrote that backwards. That should be 0, comma 1. Now sine becomes 1. Cosine is 0. And now I've got 1 divided by 0, so that's going to become undefined. Can't divide by 0. Go over to 170. Sine is 0 because that's the y value. Cosine is negative 1. And we get 0 because of 0 divided by negative 1. On to 270. 0, negative 1. The y value of that point is negative 1, so the sine of 270 is negative 1. Cosine of 270 is 0, and the tangent is undefined. And when you get back to 360, it's going to end up being the same thing as 0 because we're going full circle. So that's the unit circle, and there's another, 9, well, better yet, like 12 trig values you know just because of those 4 ordered pair. All right, put those along with these special right triangles, and you actually know quite a few exact values of trig functions, and we're going to learn how to get a couple more. A reference angle. A reference angle is a theta prime. Okay, that's what that little tick mark, how you read that. It's an acute angle that is formed with the x-axis and the terminal side is the x-axis. So our reference angle could be here. Maybe we've got an obtuse angle, so our reference angle is down there. You could have a reference angle here and here. I guess let you take a look at that picture here at the 4 different scenarios. I'm going to go through it. I'm going to practice a couple of those scenarios, but keep those in mind. You can pause it if I'm going a little too fast. So the reference angle for the following angles. Okay, I'm going to start off here by just drawing in rough sketches of the x and y axis for all these. Okay, now in red here would be the actual angles. So I'm going standard position, go at 135 degrees. Now here in blue, I have a theta prime. Now that angle is both acute, less than 90 degrees, and it forms with the x-axis. So to get that would be the leftover of 180 minus 135, or 45 degrees. So there's my reference angle for theta. All right, 210. Gonna go a little bit past 180. So there's the angle in standard position. Now here's the x-axis, theta prime, that's both acute and goes with the x-axis. Now how I'm going to get this is I've got 180 that I already went. This leftover here would be my theta prime, my blue angle right there. So I'm going to take 210 minus 180, and that's going to give me 20 degrees. Okay, 300 is my reference, or my actual angle. So here we go, wrap around. 300 puts me in the third quadrant. I've got, here is my reference angle. Now that theta prime is what's left over from the full circle, so now it's 60 degrees. Okay, 390, here we go, one complete full circle, puts me back in the first quadrant, but now my theta prime here would be right here acute with the x-axis, and I went 30 degrees more past the 360 that I needed to go. Okay, negative 100, that means I'm going in the counterclockwise position. So that puts me right there for negative 100, but the actual reference angle is right in there, and that is going to be 80 degrees. And I don't know why that drawing of that jumped up there. But anyways, that's reference angles. How that's going to help me is all these different ordered pairs off of the unit circle. Okay, notice how 30, 45, 60 are all marked. Well, so are these. Okay, in fact, all these angles on this circle I've got over here have reference angles that are either 30, 60, or 45. In fact, 45, I could fit that triangle right in here, and I could get its sine and cosine, which are the square root of 2 over 2. In that unit circle, whatever I write here for x and whatever I write here for y, that is the cosine of 45 degrees, and that's the sine of 45 degrees. So when I get over to something like 135, here's a reference angle of 45 degrees. It's going to be pretty close to the same values, but their signs are going to change. Because now I'm over here in the second quadrant, I'm going to have a negative cosine but a positive sine. Because it's pretty much the same numbers, just the signs change, I've got a little acronym to remember where all of the signs are positive. Okay, now these are where all the other angles and all the sine functions, cosine, tangent, are all positive. So here in the first quadrant, I've got all of them. So cosine's positive, sine's positive, tangent's positive. Over here, I've got students. Okay, oh, I must have, yep, I got that right. Just checking real quick. So student stands for the fact that sine is positive, and the other two then would be negative. Okay, over here I got take. So t is positive, tangent's positive. And then the last quadrant I've got calculus. So cosine's the one that's positive. Okay, now that means the other ones are positive. So if I know the reference angles, the value, so because of these special right triangles in the unit circle, and I know which quadrant they land, I can tell you what the exact value that is without a calculator. So my first steps here. First things first is I would take and I would draw, obviously, the actual angle that you're dealing with. Okay, it slipped on me again. I'm going to draw that there. Oh, what the heck. Oh, sorry guys, this is kind of messing up. I'm going to use the same color over and over. So there is 135. So my reference angle is going to be right in here. Like I said, a lot of them are going to be those exact values. I got 45 degrees. Okay, so all students take calc. Well, if I find the sine of 45 degrees, I know that is the square root of 2 over 2. That means that the sine of 135 degrees, because sine is positive in the second quadrant, is also the square root of 2 over 2. Okay, let's see the cosine of 210. Okay, there's 210 degrees. That's going to put me at 30 degrees. Well, the cosine of 30 degrees is going to be, oh, I got to double check real quick. So 30 degrees would be 1, 2 square root of 3, the square root of 3 over 2. But all students take calc. Tangent's positive, so cosine is negative. So the cosine of 210 degrees will be negative square root of 3 over 2. All right, tangent of 315. So 315 puts us in the fourth quadrant. My reference angle is 45 degrees. Tangent of 45 degrees is going to be 1. But all students take calc. Cosine is the only one that's positive, so the tangent of 315 degrees is a negative 1. Okay, negative 135, so that puts me at 45 degrees. So the cosine of 45 degrees is the square root of 2 over 2, but all students take calc. It's going to be a negative 1 because it's in the fourth quadrant, so the negative square root of 2 over 2. Okay, so that's what I got for that answer. That's what I got for that answer. It might be a little bit quick. We'll need to practice this a little bit more, but at least it gets you the heads up and kind of the information that you need to hear at least. If I went too fast, slow it down, stop it, pause it, take some notes on this stuff, guys. Write those trig values down, because the better you are at those triangles in the circle, the better you're going to be at the rest of the unit too.